Nacional. Es el profesor Pietro Teatini. Él es profesor en hidrología e ingeniería hidráulica en la Universidad de Padua, en Italia. Es el presidente actual del Grupo de Trabajo Internacional sobre Subsidencia del Terreno de la Unesco. Es además investigador asociado en el Key Lab of Artificial and Geological Disaster en Nanjing, China, en el Key Lab of Land Subsidence Monitoring and Prevention en Shanghái, China. Su investigación se enfoca en la caracterización y modelado de procesos de subsidencia, aperturamiento, sismicidad inducida, evolución de las geoformas en el Holoceno y proceso de oxidación de peatland. Ha publicado más de 150 artículos y ha sido coautor de 2 libros titulados Land Subsidence and its Mitigation and Venice Shore Rise Again, Engineering Uplift of Venice Through Seawater Injection. Y creo que un día lo vamos a invitar para que nos dé una charla acerca de este libro que acabo de mencionar, porque debe ser de muchísimo interés. Entonces, el día de hoy me da mucho gusto presentarlos y él nos va a presentar la charla de Why Land Subsidence Returning a Hot Topics in Geosciences. Entonces, adelante, Pietro. La dinámica va a ser, vamos a escuchar la charla y después los que están participando a través de Zoom pueden o pedir la palabra a través de levantando la mano o escribir la pregunta en el chat de Zoom. Y para aquellos que nos están siguiendo en la página de Facebook, que también por ahí hay muchos y los saludo, pueden escribir sus preguntas en el chat de Facebook, nosotros las estaremos leyendo. Muchas gracias y adelante, Pietro.
Okay, thank you very much to Lucia and to Dora and to all of you to invite me to give this talk. It's really, let's say, it's really a pleasure for me, and I think it's really interesting and important, as Lucia just told us, that there are more or less 200 participants, or at least registrations, so really a big number of people that has the plan to follow these topics. And this is, let's say, in some way in line with my talk. It's it is entitled in this way. Why? Let me still move this. Okay. Why land subsidence is returning a sort of hot topic in geosciences? And this is really confirmed by the number of participants, right? To this let's say 2 days meeting that we have in Mexico. So it's let's say it's not strictly a technical presentation, but it's a mixture. The idea is why we have this phenomenon, and which is why it is so important. So my talk should be follow this outline, so a short introduction to the topics, and then how we can see how land subsidence in the scientific literature has been addressed over, let's say, the last 50 decades. And then I will try to explain and to reasoning together a bit about why land subsidence is returning again, a hot topic in geosciences. This is, of course, a positive objective, but there are also some drawbacks of this. And I will try to list and to enter a bit into the detail why there is also some drawback on this effect. I will close with some more technical parts, so which are the present challenges of the research in land subsidence. And then at the end, I will provide some conclusions. So as introduction, I will start with, which is the first time that the problem of land subsidence has been associated to human activities. And this holds or happened in 1926. So in this paper, that it is entitled Local Subsidence of the Gallows Creek Oil Field in Texas, okay, published in the Journal of Geology. These two authors, Pratt and Johnson, for the first time associate the problem of lowering of the land surface to the main activities, and specifically in this case, to the removal from subsurface of oil. We are in the coast of Texas, just in front of Houston, Galveston, and a part of this area subsides significantly due to the fact that at that time that there was some oil company that removed oil from that reservoir. And they recognize, as you can see here, highlighted in yellow, they recognize for the first time that there will be the possibility that the removal of the fluid cause a reduction of the pore space, and therefore a compaction of the deep layers and this translates on the land surface as a lowering of the surface itself. So this is really the first time that we can find this topic in the scientific literature. So it is quite curious. So this is the location of the site in front of Houston, and this is an old map showing some measurements that has been carried out at that time. So isoline of land subsidence. This is in feet, so it's about 3 feet something, so more or less 1 meter of land subsidence. And it was quite, let's say, curious to understand which was the debate of this, because the problem is that at that time, let's say, the state of Texas claimed the title of some of this land that due to land subsidence was submerged. So according to the USA legislation, if land is, let's say, its land becomes submerged, then the owner lost their availability or their right to keep the land as proper land. And so at that, what's happened is that those private company and the oil company managing the gas field, they demonstrated using these two geologists, Pratt and Johnson, that land was, let's say, become submerged not by, let's say, God project, but due to the fact that they made this kind of activity. So as it is an effect of man activity, the land must remain to the property of the oil company and not return back to the state of Texas. So in some way, it is really an opposite of what is ongoing right now, because of course right now anybody wants to be, let's say, take the responsibility, okay, of lowering or land subsidence more generally. But at that time was really the opposite. Of course, there are several sites where land subsidence is really taking very high value. Here, probably these are the 3 most well-known sites where we have really meters of land subsidence. One is the Wairake geothermal field. Here we are in New Zealand. Here they develop some geothermal fields, and this withdrawal of hot water caused a land subsidence of 14 meters over more or less 50 years. So it's a really enormous amount, but this happened in sort of natural areas. So in a forest zone where there are more or less no anthropogenic activities, so very high value, but let's say the effects are really not, or the damages are not really high. Then we have a second case that you know much better than me, that it is Mexico City. Okay, also Mexico City, there are several measurements that go back to the, let's say, the beginning of the previous century. And we can clearly see that if we put together all the available information here, we have that also in Mexico City, there are portions of the city itself that lost more or less more than 10 meters, okay, due to groundwater pumping from the aquifer system. And last well-known topic, well-known site is the San Joaquin Valley in California, in USA, where there is one of the most known and most famous picture describing land subsidence. So this is Joe Poland, one of the first researchers in the world that started working on this physical processes. And he let's say, he make this picture, putting on this pole the elevation that this farmland has in 1925, 1955, up to 1977. So the problem of land subsidence is that generally is not very easy to recognize, because it is very slow, it affects very wide areas. So land subsidence is not very easily recognizable. And by this way, this strategy is make a really, let's say, a very interesting and very clear picture on how much land subsidence has affected the San Joaquin Valley in California. So if now we start looking how the topic of land subsidence evolved over time in the scientific literature, I've started to check in the publication, okay, which on the articles that has been published in several journals, in which period this article reported the maximum land subsidence for certain specific sites. For example, this map showed that when or where land subsidence site has reached the maximum values between 1920 and 1980. Okay, so the gray color means no publications in the scientific journal. When we see light color, it means one publication. The blue, the darkest one, is six value, and this occur in USA and in Japan, with some and also in Italy, with some publication in China, in Mexico, but not very much. When we move to more recent decades, okay, let's consider the period between 1980 to 2000. We can see that during this period, new publication emerged in Europe. Really significant amount of publication emerged in China, and some other in the Far East, something in Central America and in Colombia. When we move then to the, let's say, the last 20 years, we can see that the number of sites reported in the scientific literature increased dramatically. So we can see that all over the world, we have articles that discuss, debate, presents the result on study where land subsidence reached the peak during these 20 years, these 2 decades. So there is really a very strong increasing of the highest rate of subsidence rate during the last 20 years, much more than what occurred in the past. It's another research that I've done in the literature is using Scopus, and I've tried to check how many articles cite the word land subsidence in their title, abstract, or keywords. Okay, and this is the number of publications from 1970 to 2020. So we can see that in the 70s, there are really not too many, okay, only 3 publications in 1970s. And then it increased up to a maximum in the mid 80s. Here there is let's say, sort of first relative maximum with around 50 publications in 1986, where lens subsidence were directly nominated, cited in the title, abstract, or the keywords of these papers. Then we have a decrease. We go back in the 90s, so it's anymore, I would say, it's no more a fancy topic or a hot topic in the 90s. So we return back more or less as in the 70s, but you can clearly see what's happened starting from more or less 2000. So during the last 20 years, we really have an explosion of publications that directly focused on lens subsidence. We have more or less a sort of exponential increase with about 400 publications in 2020, last year. Okay, 400 publications that are directly focused on lens subsidence due to anthropogenic activities. If we look at the countries, this is also an interesting, let's say, analysis, just to have an idea. So the authors or the sites where let's say, addressed by this publication, where they come from. If we look at the 70s, okay, the author and the sites came only from the United States. So at the beginning, really, the United States was, let's say, the first area where this is really recognized as a big problem. When we moved to 1980, we can see that together with the United States, also Mexico, so Mexico City mainly, start to become a not zone, a not site related to lens subsidence. And we also have Japan in this, let's say, ranking. When we move to 1990, we start to have, let's say, Europe that start enter. So we have Italy, we have Belgium, we have Germany. We still have United States. We start having China, but you can see that these countries really have only one paper. Okay, so that they are in, but with only one publication. So still United States is the most, let's say, the country where it is most addressed by this publication related to lens subsidence. In 2000, more or less, the score is the same with larger number, but still United States, Italy, China, and some places, let's say, in Europe and also Far East, not only Japan, but also Taiwan. And now let's move to, let's say, the most recent time, 2010, 2020. And what you can clearly see is that China is really taking let's say, the gold medal, let's put like this. So they really, it's the largest number of publication is related to site in China or published by Chinese author, but also Mexico. You can see it takes the silver medal. So the second score, United States, the third one, and then all the other. If we go to the last year, okay, 2020, you can clearly see that China, it has more or less 145 publications. So almost half of the publication that was published in 2020, that are 400, almost half of them are referred to lens subsidence topics in China. And then there are still a lot of them related to United States, and you can clearly see Indonesia, Iran, Japan, so all the other, okay? But China really takes the largest part. of this. A last statistics is related to which area or subject area the journals where the publications has been done, to which area the journal are located. Okay, so generally we can see that since the beginning, so Earth and planetary sciences and the environmental sciences are the two, let's say, group subject areas where obviously let's say the publications are or the journal where the publication was done are located in. This more or less remain the same. So if we also comes to more recent time, we can clearly see that Earth and planetary science, so the more, let's say, generally the technical publication where we, as a scientist, we publish, are always the subject area where most of the publications are published. We still have also environmental sciences. We have engineering also, but it is also interesting to observe that we have also some other family of journals. We have social sciences, so there are publications related to land subsidence also in journals specifically focused on social science. We have something also related to biochemistry, genetics, and molecular biology, and to material science. So we have that during the last year, this problem of land subsidence start to enter or to be addressed also by scientists that are not strictly related to our family, okay, to the geologists or to the engineering family. And this is really also an interesting something that must be noted. So after this, the idea is it's clear, okay? We have such a big, enormous, tremendous amount of new and increasing number of publications. So land subsidence now is really a hot topic. And I try to understand why, which are the reasons of this, why land subsidence is becoming an even more hot topic in geosciences. And I listed 4 main reasons. The first one is the technology advancement. We have an increase of exploitation of underground resources. We have more researchers, and so it's become a more interdisciplinary field issue. And we also have more journals. So I spent a couple of slides for each of the topics of this reason. So the first one is that, of course, moving from the 70s up to, let's say, the last year, we really have an enormous advancement in the technology and more generally in geosciences. From my understanding, that I really work on this topic since my degree, so since the beginning of the 90s, the most important advancement that is sort of really of a revolution, and that has really, let's say, increased a lot the possibility that we have to understand this process is SAR interferometry. Okay, this is really probably the most important advancement that has really changed our way of understanding these processes, and our capability to monitor the movement of the land surface, not only land subsidence, also other kind of movements, so earthquake and also this process, volcanoes and so on, but also land subsidence. And this really is really, let's say, it has a very important effect in terms of larger coverage, more frequent possibility of checking how the displacement is going on, and also in a very less expensive way, than the previous methodology. So the traditional, let's say, spirit leveling or the permanent GPS station. So we have really, during the last, let's say, years, we had a very increasing number of satellites that give us the possibility to acquire SAR images. So the image stacks that it is now available are really enormous. We can really monitor more or less every square meter of our Earth. We had also a continuously updated of the processing chains. So not only more images, not only more satellite, but also more advanced way of managing this enormous amount of image that we have. So to be able to characterize more in detail the movement of the land surface. Another very important improvement that we have now is that with this Copernicus, within the Copernicus framework, so with the Sentinel-1 and 2, we have that the satellite images are now freely, so they are not anymore, we have not to buy, as occurred up to Sentinel-1. And of course, and also we have several bands. So the radar images is characterized by several bands, and this gives us the possibility to monitor the movement of the land surface, not only in urban areas, but also in more rural one. Just to summarize, I take two pictures just to show that with this methodology, we can really perform country scale analysis. This is a picture taken by Coursart, a publication in Remote Sensing of Environment in 2014, when Coursart author, they make this very fantastic analysis when they detected, let's say, all the sites in the central Mexico that are affected by land subsidence. So not only Mexico City, but Querétaro and all the other cities that you know very, very well. But with the same images, we can move, let's say, at a much larger details. We are able really to monitor the movement of each single buildings or infrastructure. Okay, so very detailed analysis also of differential displacement that are affecting the single infrastructure that compose our cities. And we can also perform now very detailed time analysis. So we can check how the movement rate or the movement itself change in time, each single pixel, each single reflector of these radar signals. So this is really an amazing results that give us the possibility to us to monitor very carefully this process. We had, of course, other improvement. Of course, the computer technology, the computer power increased dramatically if we move from 1970s up to now. Okay, so we have now multi-core processor. We can play with our code on GPU and more on CPU. We have cloud resources, so there are really an enormous advancement, and this of course gives us the possibility to develop much more robust data analysis, much more big and detailed numerical models. And this is, of course, an important advancement. And then, of course, we have also some big, let's say, improvement in terms of numerical algorithms. So we have, let's say, now the availability of enormous database has also increased or push us to develop new algorithms. For example, neural network-based algorithms that give us the possibility to understand which are the relationship between, let's say, the environmental characteristics and land subsidence. to really understand which are let's say, the link between the different parameters and the effect that then we observed on the lens surface, so the movement of the lens surface. Other important improvement has been done also in terms of numerics. So we have algorithms that give us the possibility to solve and to play with very big numerical models, finite element models made of millions of cells, millions of unknowns. And so let's say if we combine a much more strong of computer power with much more effective numerical algorithms, this really gives us the possibility to perform simulation and so to perform prediction on models that give us the possibility to describe really in detail the different features of the lens surface. Another important aspect is that that also push, let's say, this increase of number of publication is the fact that really there are more evident consequences of lens subsidence and really much more cases worldwide. So which are the most important, let's say, processes that we are now working on? Lens subsidence is really a dramatic effect in deltaic areas, so low-lying areas that are located at the sea level, more or less. They are really dangerous due to the fact that a lot of water is pumped from the from the aquifer system, and so we have the lowering of a land that it is already at the sea level. So the problem of flooding is really a big topic. We have that lens subsidence is really a big issue in arid regions in North China, in the Trans-Mexican volcanic belt, where we have that lens subsidence is accompanied by earth fissuring. So this formation of cracks that damages the structure, damages the environment, reduce our possibility to use our lens. And so this is something that also is really dramatic. It is really increasing in several countries, Mexico, and also in Asian countries as Iran, Iraq. So the arid region is really suffering a lot for this kind of process. We have the problem of coastal megacities. Okay, the classical one, if you want, is Jakarta. Jakarta is a city that it is on the sea, and it is subsided meters over the last 2 decades with the water really in front. So they are forced to build up walls, big and higher walls, to keep in some way safe the population from the sea. This is not a river, it's really the sea in front of the Jakarta city, the poorest suburb of Jakarta. And last but not least, it's also something that is occurring in Mexico. There was really a clear, let's say, a clear signal that when the city that it is most affected by lens subsidence and earth fissuring are also the city that the region or the part of the city that are mostly affected by seismic event. So there the land is more, let's say, is more fragile, is weaker than the other part of the city. So this is another process that really it's let's say it's really important and must be taken into account. So more evident consequences, okay? Also more cases worldwide. If we look at the publication over the last 10 years, okay, and we check simply, for example, which are the sites, the coastal site addressed by lens subsidence publication. Site where there are millions of people that live there. So we have the Nile Delta, so we are in Africa. We have the Niger Delta, Okay, so we are in Central Africa. Now also Africa is start experiencing problem related to land subsidence due to groundwater withdrawal. We have Shanghai, the coast of Shanghai. We have the coast of Ganges, Brahmaputra. Okay, then we have, in New Orleans in the USA. We have in Myanmar, so the coast of the Far East Asia. We have the Mekong Delta and the Ho Chi Minh City. Here we are always speaking about, let's say, subsidence rate of the order now of 4 centimeters. We have here the coast of Tianjin, close to Beijing. We have subsidence here on the order of 15 centimeters per year. And I would say right now, the most affected coastal area is that of Jakarta, where we have a subsidence rate up to 25 centimeters per year. So very big amounts. And you can see that they are spread all over the world. So it's really nowadays subsidence, a process, subsidence due to groundwater pumping, that it is affecting all over the world. A third reason why we have more and more publication is that, of course, we have a larger scientific community addressing the topic of land subsidence. If we go back and check what's happened in the last century, we have that the majority of the actors working on land subsidence are geologists, geotechnical or geomechanical engineers, hydrogeologists, okay? And the topic of those kind of researchers are that to measure, to test, and to model land subsidence. So the main goal is to understand the process, to predict the process. If we look what's happened over the last 20 years, we can see that there are at least 2-3 novel group of scientists that have started working, have started addressing land subsidence topic. We have physicists, we have electronic engineers, we have several marine and coastal scientists, and also we have social and economy scientists. So now the topics, the aim of this group of new group, let's say, of scientists is no more to understand the process, but better is, to monitor and to see which are the effects, mainly the effect in terms of flooding, in terms of relative sea level rise. So we could have a sort of shift of the goal from understanding the process to quantify the effects of the land subsidence itself. Last but not least, as in terms of reason, it's also the number of scientific journals. Also the number of journals increased dramatically. If we consider what's happened over the last centuries, publication related to land subsidence, they are mainly published on let's say, a sort of relatively restrict number of journals linked to association, for example, AGU, so Water Resource Research, Journal of Geophysical Research, SPE, so the group related to the oil industry, USGS, NGWA, EEE, the GSA, the Geological Society of America. This is the association, or we have also the publishers, so publishers such as Elsevier, Springer, and Wiley. But what's happened since 2000? A new big group of opportunities to publish papers also related to land subsidence emerged mainly in open access publisher. P2P, from my point of view, in some way we call it pay to play. Pay to play journals, and these publishers are MDPI, that was founded in 1996, Highway 1997, PLOS 2003, Frontiers in Earth Sciences, for example, in 2007. So these are new, let's say, new publishers that develop and put on the market really a big number of new journals address also the topic, the Earth topic, Earth science topic, so learn Subsidence too. And so we have, let's say, also a new, let's say, way of publication is special issues. So starting from, let's say, 2000, and mainly with this new type of publisher, we have really tens of special issues related mainly to monitoring and subsidence. And also we have a third group of new journals that are interdisciplinary journals, mainly related to the nature family. So we had Nature Geosciences that was launched in 2008, Nature Communication 2010, Scientific Report was launched in 2011, and also the Science Family in 2015, Science Advances. So these are interdisciplinary journals that now accept and publish also publications related to land subsidence. That was never happened before let's say the putting on the market of this kind of journal. We never be able to publish in Nature, okay? But in Nature Geoscience or Nature Communication, this is something that now is happening. What are the drawbacks, if there are drawbacks, related to such an exponential increasing interest? And I list here three. This is a personal point of view. Okay, journal-related problem, paper-related problem, and also methodological related problem. What about the journals? There are really a countless number of new journals that are mainly published by this in this form pay-to-play, in the sense that these are open access, so you have really to pay some significant amount, because it generally more than 1,000 from $1,000 to $2,000 or euros if you want to publish there. But then, let's say, your way, it's a little bit easier than the most traditional journal. The review, the processing of review of the articles on this pay-to-play journal is poorer than, I would say, in the traditional one. Some journals require to complete the review in 1 week of a paper. This is really unbelievable, right? I never consider a request of review from a journal that asked me to complete the review in 1 week. But this happened. It's happened because decreasing the time of review, this increased the impact factor. And this generally or only happen in this pay-to-play publication. And of course, with very big number of journals, it is much more difficult to follow the measured scientific advancement, because the publication are spread over tens and tens of different journals. A related problem is related to the papers. Okay, generally with this enormous increase of publication, we have really a lack of important scientific advancement. So there are generally an overproduction of minor scientific papers that are generally published in this pay-to-play, let's say, pay-to-play journal or open access journal. And in this publication, we really have generally repeated repetition of previously published work, sometimes also contrasting result on the same area, on the same topics. And of course, this has a negative effect on the reliability of our work, on the reliability of the technology, of the research, and at the end, on the ours that are scientists. And a last drawback is related to the methodology. Okay, generally, this the publication that we can find in this most recent publication, they really have a lack are characterized by a lack of in-depth investigation. Generally, the majority of them is simply a simple application of remote sensing, SAR-based application, and nothing more than this. No, the journal is simply an application of remote sensing without any kind of an interpretation. And so, let's say, the application of, and this is generally also based on the application of public available SAR-based software without any specific expertise on the people that use this software. So for example, you can find some publication where the author used persistent scatter interferometry with stack of 10 images only. And the people that, I'm not really an expert, but I've worked a lot with people that are expert in SAR interferometry. And it is well known to everybody that has a certain expertise that this sort of persistent scatter interferometry need tens of images, not very few. Otherwise, the availability of the result is extremely poor. But we can find publication like this. There's also lack of understanding of the physical process. And this is mainly due to this new, let's say, or this new methodology based on neural network that give the possibility, let's say, to link lens subsidence to, let's say, every kind of environmental variable, every kind of environmental feature, something that probably also for let's say, at least from my point of view, is very difficult to relate, or there is some relation, but it are not really the core of the process. It means that the author, sometimes you can see reading this paper that the author really ignore even the basic Terzaghi relationship. They really do not know that lens subsidence is something that happens because there is a pressure change, because this pressure change happens in some aquifer or aquifer system that has a certain thickness. And it happens because this aquifer system is characterized by a certain compressibility. These three factors that are the base of the Terzaghi relationship, of course, are very difficult to quantify because you need some investigation at depth. It is much more easy to link lens subsidence, for example, to the slope of the lens surface. Yeah, this is very easy. It's much more easy than understanding or measuring the pore pressure in an aquifer system. But it's really something that it is very, very far from really the cause of the process. A last problem, in my view, is related to lack of knowledge on lens subsidence feature. And about this, I want to mainly focus on space and time variability. So application of SAR-based interferometry clearly show us that lens subsidence is characterized by a really enormous heterogeneity in space. But if now we look at some people, mainly now we have to deal with oceanographer or people that work in coastal sciences, coastal processes, when they look at the effect of sea level rise, and these scientists, they made more or less a sort of equivalence. Sea level rise more or less occur uniformly at a very big regional scale on the order of 100 kilometers. We keep the same also for lens subsidence. And so they perform some flooding simulation using one single value over enormous scale. And they use average lens subsidence value for, I don't know, I checked one publication, for example, for the entire Mekong River Delta. The delta is 200 kilometers wide. How we can characterize lens subsidence there with only one value? These are really, let's say, this give us some really unreliable prediction of flooding, sediment redistribution, economic loss. So something that are not, let's say, not really useful for the society. So which are the present challenges? Three topics here. The first one is we have some scientific challenges within our earth science community. I focused two. I want to point out two. The first one is that, and this is what really characterizes Mexico, the Iztapalapa area. There we have discontinuous mechanic, discontinuous processes such as earth fissurings that occur into or within or merged into a continuous process that it is land subsidence. Okay, so trying to simulate or to forecast these two processes that occur at completely different scale, because earth fissures is a local process, land subsidence is a regional process. So if we want to put together and make simulation and prediction of these two processes, this is really challenging, because we have to develop models that give us the possibility to include local process into wide region. Numerically, this is really, really challenging. Another really hot topic or very challenging field is now that what we are trying to do is trying to couple huge data set presently available with physics-based modeling. So trying to couple neural network algorithms that simply try to match different huge data set with physically based model. These are the so-called PIN, physics-informed neural networks. This is something that it is really at the beginning. We start having some publication in the last 2-3 years, and it is in some way also this a frontier in the advancement of earth sciences related to the simulation, also to the simulation of geomechanical issues such as land subsidence. We have a second challenge that it is trying to, let's say, to work more in depth, to collaborate more in deep between us and scientists from other communities. So climatologists, oceanographer, geographer, geomorphologist. A challenge is trying to link or to couple what's happened on the land surface, that it is typically at the typical, let's say, field of this kind of scientists, with what happens below the land surface, so in the subsurface. And this is our field, the field of the earth scientists. And this is mainly due in order to develop more reliable prediction of the evolution, the fate, the resilience of our cities, of our coastland, plains, deltas, valley, okay? In order to, let's say, to get or to promote more reliable prediction of what the land surface, and which will be mainly on the land surface, the effect of the climate change. Last but not least is the management challenges. Management challenges, I would say that probably, at least for us, are the most difficult. So are really challenging. Most probably for us, at least for me, I would say, for generally, let's say, the earth science scientist is less attractive, but surely is the most important to help our society in view of climate change. So establish, which is these challenges, to establish really a link with social scientists, with economists, with politicians, in order to convert science outcomes into effective regulation framework or management strategies, okay, of our natural resources. So this is something that we have started to do as we also see that here in this, let's say, we have really in this conference, we have really also a lot of, let's say, technical people, but not people to work really on the science, most scientific aspect. This is really the most important point that on which we have to work and to improve for sure. And so let's move to the conclusion. So what we are experiencing is a wide and fast expansion of the scientific, social, economic, and political interest on land subsidence, more generally on geomechanical effect. This is, I would say, it's very positive, mainly for new generation of earth scientists, okay, new research and technicians, because it's a topics that it is more attracted. More attraction means also more funds to perform our research, more positions into our university to work on these topics. Of course, I would say that what I want to demonstrate in some way is that we really need a sort of driving entities to keep in some way under control this exponential growth, keeping, let's say, okay, we want more interest, we want more publication, but we really need to put sort of threshold. We cannot want to have more trash published, but we need high level research. And in this context, probably our UNESCO Land Subsidence International Initiative must have a role. This is a group that was formed in the 70s. At that year, there is only four representatives, one from the US, one from Mexico, one in Italy, and one in Japan. But this group grows significantly. This is in 2000. So in 2000, we have more or less 12 countries that has been represented up to 2017. In 2018, with the DORA, and together we really work a lot within UNESCO, and we move from a working group to an initiative. This gives us the possibility to expand even more. So we really want to involve more researchers from developing countries that are now start facing the problem of land subsidence. For example, Bangladesh, Cambodia, India, Iran, Vietnam, in Africa, Nigeria, Sierra Leone, and so on. But also we want to involve more young researchers from the already represented countries. Okay, so we have, let's say, established a new figure that we call it associates, and every new researchers that want to work on this topic and want to collaborate within this group, funded or managed within the UNESCO family, can apply into using through our website. And this is the end. Thank you.
Muchísimas gracias, Pietro, por tu charla muy informativa, porque nos enseñaste un panorama completo desde cómo se estudia el proceso, cómo ha evolucionado en el tiempo, hasta problemas que creo son característicos de cualquier disciplina en la actualidad en cuanto a las revistas y la calidad de las publicaciones y cómo sí, esa tendencia, ¿no? De ver el número más la cantidad que la calidad. Y eso es un problema en todas las disciplinas. Y en todos los países, dependiendo de los criterios que usan para nosotros para evaluarnos. Tenemos unos espacios para algunas preguntas. No sé si en la audiencia aquí en Zoom alguien quisiera tomar la palabra para alguna pregunta o comentario. Lo mismo estoy preguntando en Facebook para poder... aquí tenemos ya... Si quiere, Marco, puedes prender tu micrófono, Marco Antonio Rubio, y expresar tu comentario que acabas de poner en el chat.
Hi, everybody. Can you hear me fine?
Yes.
Well, I just wondering. Very nice talk. Congratulations. I just noticed that we made a lot of papers and a lot of technical information, but we didn't change the behavior or even the rules of how to manage this kind of risks. So the question is how to modify, how to put this information in the hands of the people that take decisions. Thanks so much.
Yes, I perfectly agree with you. And this is why I put these topics as the last and probably the most important challenges that really we have to face. It's not really easy. It's not really easy. I would say at least in some countries, in Italy, for sure, it's really a big problem. So politicians, technicians, they do not really, so that they take their decision also with respect to environment and to the topic of land subsidence. Really not using what we say, let's put it like this, or what we write. So probably this is also could be the default, I would say, is half and half, 50% probably to us and 50% to them. We have to find a new way to communicate. This is for sure. I don't know in Mexico, which is the situation. I know, for example, that there are some countries where this link between scientists and politicians, scientists and technicians work perfectly. And the most, the example that I have is the Netherlands. The Netherlands, you know, it's really a country where its subsidence is probably one of the most important problem in the near future, because half of the countries is below the sea level. So there, the link between scientists and politicians works perfectly. So the politician really asks to the scientists to make suggestions, and they follow the suggestion, even though these suggestions are not popular. Just an example, they have some problem, for example, on to oil production and hydrocarbon production. When scientists demonstrate that this link is really strong, so that part of seismic event are for sure related to the fact that they produce some hydrocarbon, the government stopped the production. So now NAM, that is the Netherlands oil company, they have only 2 years to close the production, no more, there is no way, even though this is clear, a very, very well linked. They know that removing water, this causes land subsidence, removing water from aquifers. In a large part of the Netherlands, you cannot drill new wells, you cannot withdraw groundwater. Of course, I would say they are lucky because they have sufficient water anyway, but they really by law prohibit this sort of effect. So there are countries where this works. Unfortunately, the number of countries are not so big, but so we have really, I agree, we have really to improve on these points.
Muchas gracias. Dario Solano, si quieres tomar el micrófono.
No, just one, I simply read, thanks, Pietro. Then we need politics with more technical background, I guess. I perfectly agree, totally agree with this.
También en Facebook hay un comentario al respecto, perdón, en donde proponen que INEGI puede ser la manera de conectar los políticos con la ciencia para trabajar mejor el aspecto de subsidencia. Perdón, Dario, adelante.
Yeah, thank you. Yeah, I'm just wondering about your opinion on the, in some different disciplines, we use different terms, and we refer to the same problem with different words. Just for instance, we say Mexico City is sinking or Mexico City is subsiding.
Yeah.
And we try to refer to the same thing, but it's not the same. And we have that problem in English and in Spanish, and not only with that, but with the term, for example, fault, crack, fissure. All of that makes, like a huge mess sometimes, and it's difficult to talk with people from different disciplines. So what's your opinion on that? What can we do in terms of trying to unify the terminology in our community? Thanks.
Yeah, this is nice. This is also, I agree with you. So it's there is some difficulties in using the terminology. Probably, let's say, also because English is the official terminology, but let's say the majority of the people that work on these topics are not, let's say, native English languages. Okay, only in the USA, let's say. But I agree. So, for example, at least for me, sinking or land sinking or land subsidence is more or less the same terms. But for sure, I agree that fracturing or earth fissure are completely different processes. How we can manage? We had an idea in a sort of let's say a preliminary idea that we are not still able to put in place, but it should be to try to, let's say, make a group of scientists that work together, develop a sort of, let's say, dictionary of words related to the problem of land subsidence and associated land subsidence, and publish this sort of dictionary. This idea, I taken this idea from a publication that was made by the people that work on sea level rise. They have the same problem with eustatic rise, sea level rise, mean sea level rise. So also in that field, they have the same problem, and they publish this nice paper where they make a sort of really review of the different meaning of the different terminology, and this is for sure a problem. So I revised a lot of publication where mainly, for example, mainly from Chinese scientists, where the difficulties is even more larger. Okay, because of course you can. It's obvious they use a completely different languages, where for them the formation and movement are the same. So they say that SAR interferometry measure compaction. No, it's completely wrong. They measure displacement. They do not measure deformation. So I think this could be a way. So if there are some of you that want to help us, I think this could be a good idea to try to develop a sort of publication where we make a sort of clear sort of dictionary of all the technical terms that are related to these topics, and make very clear for everybody.
Muchas gracias, Pietro. Si
Thank you.
quiere, Dora, un pequeño comentario al final, y creo que otras preguntas que vayan surgiendo las podemos después retomar en la mesa de discusión. Entonces, Dora, si querías comentar algo, adelante.
Yes, thank you. Thank you, Pietro, for the great talk. As always, you gave us a great scope about all the aspects of land subsidence studies. It's an interdisciplinary work, and it's not only in the earth science or mathematical science, but also, of course, in the social and political science. Yes, we need to educate our politicians, but we also need to change our way to be evaluated as scientists. I don't know in Italy, but here in Mexico, we are evaluated only by numbers and by publications. If you make any kind of social work, for the most of the people, is a waste of time as scientific, and they say it's not worth it, but it's so wrong, this kind of evaluation. I think we are changing little by little, but it's really a hard way to go with it. We are working for 13 years with Iztapalapa, and all my colleagues can agree that it's a hard way. So I think we need to approach in both
Of course, both directions. Yeah, for sure. I perfectly agree. Yeah.
Thank you very much, Pietro. Great, as always.
Okay.
Very nice.
Thank you.
Perfecto.
Hay otra Dora
Muchísimas
Carreón.
gracias.
Perdón, Lucía, como compartí mucho mi liga, va a haber muchas Doras Carreón ahí pidiendo.
Ya vi. Te duplicaste. Pero hay más preguntas, pero yo creo que las dejamos para no retrasarnos mucho en el tiempo. Entonces, nuevamente, muchísimas gracias, Pietro. Y seguimos con